Here I want to demonstrate some different charts you can generate using Python. So for this demonstration, I'm using a housing sales dataset, and the columns I'll be interested in will be the price, maybe the number of bedrooms, the square feet living area, the square feet lot area. We can expand this to consider more columns as well later, but just for this short demo, I'll use only some columns from this dataset which I downloaded from kaggle.com. So I'll just restart the kernel. I've imported pandas, numpy and plt. Okay, so this I'm reading the file. Get the top 5 rows. So in some rows year renovated is 0, so probably information not available, so it's not going to be important in my data. uh, Describe actually computes some exploratory data analysis values like mean, standard deviation, the first quartile, the third quartile, the median. But since it does this as calculations, it shows them as floating point numbers with number of decimal places. For simplicity, I just convert them to integers here. I do a describe as integers. So the mean sale price is 240,000, the max sale price is 300,000, the median is 249,900. Similarly, you can look at bedrooms. They go from bedrooms go from 0 to 7. Okay, but most of the bedrooms you can see are 3 bedrooms. 25th, the first quartile, median and third quartile are all 3 bedrooms. Square feet living area and square foot of the plot of land. So there are some with there's probably some with a very large plot of land, and some very small houses with small plot of land as well. I can compute the most frequently occurrences. Remember, this described just shows you the mean, median and the quartiles and standard deviation. But if you want the most frequently occurring values, you can actually do a mode. So even for the date also I can get the mode. So most sales are on this date. Most frequently price is 300,000. Most frequently sold are 3 bedrooms. Of course, it doesn't mean that the square houses with 1200 square feet are all 6000 square feet lot. So these are not the same row, these are all from different rows. 3 bedrooms is the most frequently occurring, but doesn't mean that all the houses, 3 bedroom houses are 1200 square feet living in 6000 square feet lot. These are all independently calculated mode values. Okay, so just remember that. But you from this you can interpret the most frequently occurring number of bedrooms is 3, most frequently occurring price is 300,000. I can just look at the sale date ranges. Sale is a string, but I can see that is from 2nd May 2014 to 14th May 2015. Now first chart I'm going to compute is a bar chart. Okay, for number of houses sold by bedrooms. Now I know bedrooms range from 0 to 7, minimum 0, maximum 7. So on the x-axis I use numpy range from 0 to 7, that is 0 to 8 with step by 1. On the y-axis I do a group by bedrooms and count the number of sales by bedroom. Colors I cycle through red, green, blue, purple, and then I print a title. So I'll just show you this. So most of the houses are 3 bedroom, some are 2 bedroom, some are 4 houses, and the colors cycle through red here, 0 bedroom, green, blue, purple. Because I have not specified as many colors as there are different bars, they cycle again red, green, blue and purple. Okay, but we know 3 bedroom is the most number of houses sold. So another way to do is a pie chart. So again I'm going to group by the bedrooms. Okay, so first I will just show you, for example, instead of plotting the pie chart, I will just show you the values again. So 0 bedrooms 7 houses, 3 bedrooms 2618 houses, which is the most frequent, and you can see it matches this. 4 bedroom is 804 and 7 bedroom there are 2 houses. Okay, now I'm going to plot the chart and I can specify a size also. So my index is, that is for each pie in the chart I'm using the number of bedrooms because that's the index here, 0 to 7, and the value in the chart will be the bedroom count but automatically computed as a percentage. So the first simple pie chart I'm going to plot is the from this data frame which I've extracted as a grouping of sales by bedroom. Just run this again. Now I've got this chart houses sold by bedroom count, three bedrooms, two bedrooms, one, and you can see there's a lot of overlap here, and they're all meeting in the center. All the slices are meeting in the center. So what we can do next is we can use the explode function. Now we know, for example, 0, 1 are small number of sales, maybe 6, 7 are also small number of sales, even 5 is a small number of sales. So what I do is for 0 I use an explode factor of 0.4, for 1 bedroom 0.3, and so on. Then for 7 bedrooms 0.3 explode factor. And now I also include a shadow. I add a shadow here in this chart. So again I compute the, so this is my second chart. You can see the explode is done. So 0 bedroom is moved furthest out, 0.4 factor. Then 1 bedroom is moved out 2.21%. You can actually calculate 101 is 2.21% of the total 4570 rows. So because I used explode here, 0 bedrooms exploded further south, then 1 bedroom with the explosion factor 0.3 and so on. 0, 1, 2, 3. But this is running counterclockwise. So I can do the same thing again. Set counterclock to false. I can increase the explosion factor also and increase the figure size. So I do that as again. Now we increase the figure size from the initial value of 6 by 6. I've increased the figure size by 10 by 10. Then I've set to counter clock. That means 1, 2, 3. It goes like this clockwise. Instead of earlier, the default was 1, 2, 3 counterclockwise. So now I change to false. 1, 2, 3. And because the size is much larger and explosion is higher, you can see the 0 exploded further out. 1, 2.21 is very clear now. 6 is also clear, 0.44%. 7 and 0 are still too small to be very clearly visible. But each of the slice has its own shadow. So for the slice of 3 bedrooms has a shadow, slice of 2 bedrooms has a shadow, and so on. So you can incrementally keep adding factors like counter clock, explode, percentage, and shadow. So I just should have converted this to markdown and run this. So I use explode to carve out the slices with smaller values. First my explosion is 0.4, 0.3. Then I increase the explosion to 0.6, 0.4. So 0 bedrooms and 1 bedroom exploded further out. And I use counter clock to change the direction from a counter clock to clockwise by setting counter clock to false. And I use the shadow also. So in your pie chart you can incrementally build the pie chart the way I demonstrated here. Another chart I can do is a box plot. So this is again I get the number of bedrooms, I sort it, then I'm going to set the title and the labels, and then for each bedrooms count I create a list, and then from this list I'm going to plot the box plot. So let me run this. So this is my box plot. So this indicates that houses with 0 bedrooms have this range of prices. The median price is the yellow bar, the third quartile is the upper, the first quartile is the lower, and this represents the interquartile range. 3 bedroom houses have a lot of outliers beyond the interquartile range. 7 bedroom houses is the highest price. So this generally indicates the more the number of bedrooms, the higher the price, but it also shows you that houses with 3 bedrooms have a wide range of prices. One more chart I can do is scatter diagram or square feet living with square feet lot. If I scroll up again, let me show you square feet living. The house area and the plot of land is the square feet lot. So you have one is 1.16 million, one is 572 square feet plot of land, and living area is 290 square feet. So you can do a scatter diagram as well. And in this case, on my x-axis is the living area up to 3000 square feet, and the y-axis is the plot of land. So you can see most of them generally are aligned, although there is one house with a very small living area but very large plot of land, and there is one house with a very large plot living area but not a large plot of land. So these are definitely outliers. Small house if you go by the x-axis and large plot of land. Large house but small plot of land. I can invert the chart, change the x and y axis and view it differently. It's the same chart but I'm viewing it differently. So this is a scatter diagram. This is a box plot. This is a pie chart where I incrementally built the pie chart starting with some default values and sizes. Then I used explode to move them out. So explode 0.4 for 0 bedrooms, 0.3 for 1 bedroom and so on. Then I use counter clock to change the direction and I increase the size further so that I can see the values much better. So these are examples of what you can do with data, and this was the data I used. This is a data set I downloaded from Kaggle. So far I have not done all the columns. We could also look at floors, or we could look at condition and grade. We could plot by year build. We could do plots by zip code, which for example, which is the most frequent zip code and how many sales there are. We already know from the mode values the most frequent zip code is 98023, so we could actually do plotting just for this zip code alone. So these are some examples. I will upload this CSV file and this sorry this Jupyter notebook to my GitHub page and give you the URL in the comments in this video.